Today we will be in Chapter 3, Section 3, Geometric Problems. The first part of your notes for this section will be about triangles, and then I'm going to open up a handout from Chapter 2, Section 6, and that will have a table that'll be the second part of your notes. And then after that there's another handout for the actual homework problems for this section that we will work through together. So first, let's talk about triangles. Triangles are a three-sided polygon. That's probably a duh moment for you, but something we needed to address. And then the measure of the interior angles added together will equal 180 degrees. So if you look at that triangle, notice I've labeled angle A, angle B, and angle C on the inside. And if you add all three of those angles together, you're going to get 180 degrees. Now, there's a couple of different types of triangles, so I'm going to give you examples of all of these. You could see these in your problems. I'm going to slide up. The first type of triangle that you could encounter is known as an equilateral triangle. These triangles, all the sides are the same length and all of the angles are the same. And so there's a picture of the triangle. Notice there's a hash mark through each side. That means that each side is the same. And then I've also marked the angles. Whenever you're looking at a picture of a triangle and you see the angles marked like that, that means that they're all the same measure. So all of those are the same. Okay, let's look at number 2. The second type of triangle is known as an isosceles triangle. These have two sides that are the same length, and the two adjacent angles have the same measure. So it's a little bit hard to draw these to make it really noticeable, but I did my best, and hopefully you can tell that the side that I did not mark with a hash is quite a bit longer than the other two. So the two sides that have the hash mark are the same length, and the two angles that are marked are the same measure, and that will be an isosceles triangle. Notice I didn't mark the other side and the other angle because they're not equal to anything. So when you're looking at a standard picture like that, you just don't mark them if they're not equal. Alright, the third type of triangle is known as a right triangle. The distinguishing feature on these is that they have one angle that is 90 degrees, and that's the angle that has the little box in it, and that's how you mark a 90-degree triangle angle, is with that little box. The sides aren't the same, but they do have a right angle. Okay, there's one more type of triangle, and it's one that you don't see very often, but still needs to be addressed. And it's called a scalene triangle. This triangle has no sides that are the same and no angles that are the same. So notice there's nothing marked on that triangle at all because nothing's equal. The inside angles still add up to 180 degrees, just like in all other triangles, but none of the three angles are equal to any of the other three angles. So those are the 4 types of triangles you could encounter when you're doing these problems. There's also 2 different types of angles that you could encounter. I'm going to try and put all of that up there at once for you. The first type of angles that you can have are known as complementary angles. These are angles that add up to 90 degrees. So there's a picture, and notice there's angle A and angle B. And if you add those up, you're going to have 90 degrees. Remember, when we have a 90-degree angle, we usually mark it with that little box in the corner, like that. So those are complementary angles. The second type of angles that you can have are known as supplementary angles. Those are angles that add up to 180 degrees. So 180 degrees is a straight line. So notice we have angle A and then angle B. And if we add those up, we get 180 degrees, which is a straight line. And I'll write that beneath there. So a lot of your notes for today, I mean, that's the majority of the notes you're actually writing down, but most of your notes for today are kind of reference notes, things that you'll go back to reference when you're doing a problem, but not necessarily things that you have to 100% memorize. A lot of these are things that you'll use over time, and as you use them, you'll just get used to them. Okay, so the next part of your notes is actually going to be found on the Course Compass site. So I'm going to get that opened up and then show you where to access that information. Okay, so when you get your Course Compass site opened up, you need to go over to the left-hand side and click the Course Document/Videos button. When you do that, you need to also then go to the Handouts button. And I know that there's a handout for 3.3, but we're finishing our notes right now, so I need you to click the handout for 2.6. And when you do that, it will take you to a handout that looks like this. And that's a formulas handout. Hopefully you've already opened this and worked through these back in chapter 2.6. But the reason I have you open it now is because there on page 2 is a really nice table of geometric formulas for a whole bunch of different shapes. And so this table has both perimeter equations and area equations for the square, the rectangle, the parallelogram, the trapezoid, and the triangle. So remember, perimeter is the sum of the lengths of the sides of a figure, and that's usually known as P for perimeter. The area is the total surface within the figure's boundaries, known as A. So if you look at this graph or this table, it has a picture, and then it shows you what the area equation would be and what the perimeter would be. So I'm not going to go through all of these because, again, your notes for this section is more for reference than it is a sit down and memorize these. I will tell you, more than likely, the only ones you're going to be working with are going to be the rectangle and the triangle. But I give you more because there is a chance you could see these, and you'll definitely see these in future math classes. So this is a great table to have at your disposal. Okay, so now that you've kind of looked at that, I need you to open up the 3.3 handout. Okay, when you get the handout for 3.3 opened up, this is what it looks like. I believe there are 5 problems, 3 perimeter problems, and then 2 triangle problems to work through, and I've gotten these straight off of your notes. I just made a handout because I think it's a little bit nicer to use. So we're going to work through these right now. So let me pull my paper over there, and we're going to work the problems. So problem 1, whoops, don't cheat. Problem 1 is a perimeter problem, and it says the length of a rectangle is 15 feet longer than 3 times the width. If the perimeter is 350 feet, find the length and width. Okay, so it says it's a rectangle. So if you're looking at your 2.6 handout, we know that a rectangle, it looks like this, with the width and the length. And we know that this is a perimeter problem because it said it was a perimeter problem. So the perimeter of a rectangle is 2L plus 2W. So that's the equation we're going to be working with. And then from our problem, it says the length of a rectangle is, and if you remember how to dissect word problems, anytime there's an is, that's an equal sign. So we know that the length is 15 feet longer than, so that's 15 feet longer than something else, and our something else is 3 times the width. So that would be 3W. So now we have the perimeter is 2 times the length plus 2 times the width, and we know the length is 15 plus 3W. It also goes on to tell us that our perimeter is 350 feet. So our P equals 350 feet. So it means we can rewrite that top equation as 350 equals 2L plus 2W, because our perimeter is 350 feet. Now, we know what our L is. It's 15 plus 3W. So let's plug that in to that equation so we can have one equation, one unknown. That'll be 350 equals 2 times, we're going to put in 15 plus 3W, and then we saw the plus 2W out there from our equation. So now we just need to work through this. We need to distribute in that 2, and hopefully by this point you guys should just be able to knock out this problem. Once you do all that, you should get 40 equals W. So that means our width is 40 feet. Okay, so that's half of it. But if we know what our W is, we can plug that in to our length equals 15 plus 3W. We know our W then is 40. And we should be able just to work this out. So we got our length is 135. Let's check our answer. And I say let's check our answer because I loaded an answer key on your course compass site, and notice it even shows you all the work that I just did. So hopefully this will let you go back and redo these problems and just continue to work through them time and time again to get more practice. Okay, let's move on to number 2. I'm going to scroll up and then I'm going to block the answer. Scroll up on my paper down here as well. Okay, it says Christine is building a sandbox for her daughter. She has 30 feet of lumber with which to build the perimeter. What should the dimensions of a rectangular sandbox be if the length is to be 3 feet longer than the width? Okay, again, it said we were doing a perimeter problem and it said we're doing a rectangle. So we're going to have another rectangle. And the perimeter of a rectangle is 2 length plus 2 width. That's nice. she even told us that she has 30 feet of lumber to use. So she told us our P is 30. So again, we can write that as 30 equals 2L plus 2W. Okay, let's see what else she gives us. It says the length is to be 3 feet longer than the width. So we have the length is to be 3 feet. Longer than would be double or plus, and then our width. Again, we're just going to substitute that in and work it out. So anywhere that there's an L in this equation, we're going to put in the 3 plus W. And then let's work it out. Hopefully, you end up getting 6 equals W. So that would be our width equals 6 feet. Again, once we know our width, we can just plug that in and solve for our length. Because our length was 3 plus W, so that would be 3 plus 6, which is 9. So our width was 6 feet, and our length was 9 feet. Let's check our answer. Look at that. We did it right. Good for us. Let's go to the third problem, the last of the perimeter problems and the hardest, but this one always shows up, so we had to address it. And I even gave you an additional picture to go along with this one because it's important to be able to identify this picture. And when you're working this one on your homework and quizzes, it gives you this picture as well, or a very, very similar problem. So I wanted to make sure and work through this one with you. Excuse me. So it says Yates is starting an ostrich farm. He is separating the ostriches by fencing in 3 equal rectangular areas as shown in the figure below. The length of the fenced-in area is to be 30 feet greater than the width, and the total amount of fencing available is 660 feet. Find the length and width of the fenced-in area. So again, this is a perimeter problem. He even tells us how much our perimeter is. So we have perimeter is 660 feet. Now that's all good and dandy. Let's go back up, and it says the length of the fenced-in area is to be 30 feet greater than the width. So we get length is to be 30 feet greater than the width. Now, when we're doing perimeter problems of rectangles, like we've been doing perimeter equals 2L plus 2W. That's what we've always been doing. But my question to you is, how many W's do we have in this case? And that might be a weird question, but if you look at it, we have L up here, whoops, which is this whole side, and then we have the same thing down here. We have this L down here, so that's where we get our 2 L's from. But how many W's do we have? We have a 1 W here, 2 W's here, 3 W's here, and 4 W's here, because we're dealing with more than one rectangle in this case. So instead of having 2L plus 2W, as we usually do, our perimeter equation is going to be 2L plus 4W. So that is the big thing with this problem, is we have to go off the picture they give us so we know how much fencing to actually use. Because we have to put fencing up in this section and in this section as well, not just all the way around the outside of the big rectangle. So that's why we have to include this W and this W. Okay. So we get to do all the substitution in. Again, we know P is 660, and then our L is the 30 plus W, and then outside of that we'll have plus 4W this time. So you should get 100 equals W. Okay, again we're just going to substitute that back in. We know our length was 30 plus W. So plug in 100 for our W. And we get 130 is our length. Let's check our answer. And we got the right answer. Again, this problem right here with the multiple rectangles always comes up on your quizzes. So make sure you know how to work through this one, okay? Let's go down and knock out our 2 triangle problems, and then we will be done. Okay. We have the cat has a corner lot that is in the shape of an isosceles triangle. Alright, so right there you need to remember what an isosceles triangle is. If you need to open your notes back up, that is fine. I'll throw mine back up there for a second. An isosceles triangle looks like this. It has 2 sides that have the same length, and then the 2 adjacent angles have the same measure. Okay, so I'll draw that over here on this paper. So we have an isosceles triangle, whereas this one and this one are going to match, and this one and this one are going to match for this problem. So it says 2 angles of their triangle lot are the same. It even told you that. And it says the third angle is 30 degrees greater than the other 2. And then we need to find the measure of all 3 angles. Okay, so we're only worried about our angles in this problem. We don't have to worry about the sides or anything else. So remember what I said at the beginning, angle A plus angle B plus angle C of a triangle equals 180 degrees. Always, always, always. So if we want to say that this is angle A, that's great. But what do we know about this angle and this angle? We know that these are the same. These are going to be the same number. So instead of calling this angle B, we can just call this angle A again. The reason why we're doing that is because we want to get one equation, one unknown in order to solve this. So we need to figure out what this angle up here is. And it tells us that the third angle is 30 degrees greater than the other 2. So that means this angle in here is going to be A plus 30. It's going to be whatever the measure of one of these angles is plus another 30 degrees. Oh, sorry about that. So the reason why we did that is because now we have the measure of angle A plus the measure of angle B, which we said was A, plus the last and third angle we said is A plus 30. And all of that equals 180 degrees. So now we just need to solve this to find our 3 angles. So we have 1, 2, 3 A's plus 30 equals 180. Subtract over my 30 and divide by 3, and you get 50 degrees as angle A. Now remember, angle A is also angle B, so our two smaller angles are 50 degrees, and then our larger angle was A plus 30. And if we said A is 50, that means our larger angle is 80 degrees. So on these problems, they're going to ask you to type out all three of your angles. So you'd have angle 1 would be 50 degrees, angle 2 would be 50 degrees, and angle 3 would be 80 degrees. And notice if you add 50 and 50 and 80 together, you get 180. So that's how you would do that problem. The important thing is to remember the isosceles triangle has two angles that are the same and then one angle that is not. But that all three of these have to add up to be 180 degrees. So let's see if we got that right. And angle 1 was 50, angle 2 is 50, angle 3 is 80 degrees. We did it. All right, one more problem, and then you can go get started on your homework. Okay, this one says, in an isosceles triangle, so right there we're doing the same type of triangle we just had on the last problem, where we have two angles that match and two sides that match. So in an isosceles triangle, one angle is 42 degrees greater than the other two equal angles. Find the measure of all three angles. Okay, so we're working this one exactly the same way. We know that these two are the same, and we know that this one from our problem is 42 degrees greater than the others. So this one's going to be A plus 42 if we let both of these be A. So we just need to add all those up and let them equal 180. So we have A plus A plus A plus 42 equals 180. 3A plus 42 equals 180. 3A equals 138. If we divide by 3, we get 49. So angle A should be 49, which means there's two of them that are going to be that way. And then we have A plus 42 as our third angle. So that would be 49 plus 42. And that would be 91. So you get 49, 49, and 91. Is that right? 46. What did I do wrong? I divided wrong up here. Sorry. That's 46. Thought that seemed high. I'm sure some of you out there caught that and were like, hey, you're wrong. The joys of online classes, though, I can't hear you yell at me. So sorry about that. It's 46. I tried to divide in my head and didn't get it right. So your two angles would be 46 and 46, and your bigger angle would be 88. If you do not like geometry, and if this stuff is way over your head or just seems kind of like it's out of left field, since it's right at the end of the semester, I know it is. This is one of those extra sections that we try and get in because you're going to see it again in future classes, and so it's good for us to cover. But let me reassure you that you can get through it, and remind you that you get to use your notes on your homework and your quizzes, and even on your section tests. And you do get a cheat sheet for your final exam. So please don't stress trying to memorize all these area and perimeter equations. Should you know that the angles add up to 180 degrees? Yes, you should. And so that should be able to help you with all of your triangle problems. If you need more help, just keep looking at 3.3 handouts and using your similar exercise button in your homework sections, and that will really help you out. So good luck on your homework and good luck on your quizzes.